Hello students, welcome to the course of Database Management Systems, which has a code of CS222. I am Dr. Munir Umar. As per the KCMS activity number 21 and our course plan, today we will be studying integrity constraints in the database management systems. These are the main contents of our today's lecture. First, we will look into some sample cases, and in these cases you will see that how can we face some issues in the databases. Then we will define the integrity constraints, and after that we will look into the types of integrity constraints, which are domain constraints, entity integrity constraints, referential constraints, and key constraints. With each type we will have some sort of definitions, and also we will look into some examples. So first, start with some cases. Case number 1. Here we have 4 tables, and in each table there are 3 attributes. So first we are going to check the table number 1. It has employee name, position, and salary. Now if you look into the values or the tuples of this table, you will find some sort of error in this table. Here we have salary attribute, so it is obvious that the salary must be in decimal, or simply you can say that there should be some numerical value for salary. So if you look into the third tuple for Ghulam office assistant, the salary is typed as moderate. So this is a non-numeric value, and with this value we cannot determine the exact amount of salary. So this is an issue in the records of this table. So we must say that it should be a numeric value. Then if we look into another table, here we have age. So for age, again we need a numeric value, and if you look into the third entry, this age is not clear. This might be a mistake. So here the age must be numeric value, so this is again an error. Third, we have marks. Again, marks must be in numeric form, and here it is a non-numeric value, and with the help of this value we cannot determine the exact value for marks. In the last table we have date of birth. So if you look into the last entry in this table, this date is invalid or incorrect because we don't have these values in dates. So we must say that the date of birth must be in date form, so we can assume that this must be typed incorrectly by the operator. Then case number 2, here if we look into these 2 tables, the records in these tables are identified by some IDs or some key values. So for student we usually use student ID as a primary key to determine the records of students. So if you have student ID, then you can get the record of that student. But here in this table, the third entry don't have any ID, so this record cannot be selected or extracted from the database. So this is also an issue. Here in case of vehicle, we don't have value for the primary key attribute, so this vehicle cannot be searched in the database table. It cannot be uniquely identified, so this is also an issue. Third case, here 2 tables are connected. So if we look into these 2 tables, this first entry is connected with this one. So if I say that
the father name of Ali is Fazal, then it would be actually due to the connection of this parent ID. We are using a foreign key in this table from here, so both the tables are connected, so we can get the corresponding value of this table here in the second connected table. So then we have P007. This value is not present here. So if I say that I need the father name of Ahmad and look into this value, but here I will see that this value is not present in the second table, so this will cause an error for me. So the condition for this is that the value must be either present in the second connected table or it must be null. In the last case, here we have another thing that is also associated with the primary key. If you look into these records, you will find the duplication of primary keys. Usually we use this primary key values to uniquely identify the tuples in tables. So if I search for this record 1002, I will get Ahmad as well as Ghulam, which is incorrect. So each student must be identified by its unique registration number, and the registration number cannot be duplicated. We are using registration number as a primary key in our table, so it must not be duplicated, otherwise we will get error for such type of things. Here in case of vehicle, we have two vehicles having same registration number, which is obviously not possible. So this is also a case, and we may face errors or issues with such type of values in databases. Now we are moving towards the integrity constraints. So integrity constraints can be defined as that the integrity constraints are a set of rules, and these constraints are this set is used to maintain the quality of information in a database. Integrity constraints ensure that data insertion, updation, and other processes on the data have to be performed in such a way that the data integrity is not violated. We checked the violation of data in previous cases, like there for salary we found moderate value instead of a numeric value, so that was actually violation of integrity of data. So these rules are used to guard against accidental damage to the database. Actually, when we design a database, we program our interface to let the user enter correct values, or simply say that we put some rules so that the user cannot enter a wrong value accidentally. Now moving towards the types of integrity constraints. So here we have four types. The first one is domain constraint. It is about the domain of an attribute, or say that the possible values for an attribute. As we noticed in the previous cases, that for age the possible values were numeric values, or if you specify these numeric values, then you can say that these values must be positive decimal values. Then the second one is entity integrity constraints. This type of constraints are associated with the primary key of a table. Usually we check the value of primary key whether it is null or not. If the primary key value is null, then there would be violation in the data integrity. Then we have referential integrity constraint. This type of constraint focuses on the connectivity of two tables. If two tables are connected, there is some sort of relationship between the two tables, then it must also follow some rules for the connectivity of the instances in both the tables. Then the last one is key constraint. The key constraint is also about the primary key, and in this constraint we will check the duplication of primary key values. First, we have domain constraint. Domain constraint can be defined as the definition of a valid set of values for an attribute, or simply say that to define the possible values for an attribute. As we saw that for salary, the possible values are decimal values or numeric values. The data type of domain includes string, character, integer, time, date, currency, etc. The value of the attribute must be available in the corresponding domain. Here we check two things. The first one is data type, that whether it is string, character, integer, time, etc. And the second thing is the range of values. Like for salary, we consider integer, then we must also specify that the value must be greater than 0. The next constraint is the entity integrity constraint. In these constraints, we look into the value of primary key, and it states that the primary key value can't be null. It is because that we use primary key values to uniquely identify individual rows in a relation. Suppose we have a table for some students. So for each student we must have a registration number, so that we use that registration number to uniquely get their values. Here we have a table, so in this table there must be registration numbers for all the students. Suppose here we have two students having same name. Let's say this one is Ali, and let's say the second one is also Ali. So it is obvious that two or more persons can have same name, but their record would be definitely different. So we must uniquely identify these two Alis with their registration numbers, which would be different. And there is another thing, that suppose we don't provide the registration number for a student record, then we may face issues with that record in case we get two ghulams, both have null. So in that case we will not be able to get the exact record or the unique record of an individual ghulam. So this rule specifies that the primary key value can't be null, because the primary key is used to identify individual rows in a relation. If the primary key has a null value, then we would not be able to identify those rows. A table can contain a null value other than the primary key field. Suppose here we have age, so it is possible that we don't provide value to this age, but this primary key is essential and it must be provided. Next is referential integrity constraint. This constraint is about the connectivity of two tables. Actually, we reference some values of one table in another table, so the values must be referenced properly. So the referential integrity constraint is specified between two tables, and in referential integrity constraints, if a foreign key table 1 refers to the primary key of table 2, so here this one is foreign key and this one is primary key. So if this one is referring, this foreign key is referring the primary key of second table, then it's okay, it's not violating. Else, if we have some values which cannot be referred in the second table's primary key, then we would say that there is some sort of violation. Now if we look into this table, here we have a value which is not present in the connected table, so this is wrong. We can either provide null or we must provide a value that is present in the connected table. The last type of integrity constraints is key constraint. This type of constraint is also associated with the primary key. Here we specify or we clarify that the primary key must be unique and it must uniquely identify a record in the relation. Keys are the entity set that is used to identify an entity within its entity set uniquely. The entity set can have multiple keys, like here we can also use, let's say, name is a key, but out of which one key will be the primary key. So here we have primary key in this table. The student ID is usually used as a primary key, and we use this student ID to identify the records of individual students. So primary key can contain a unique and not null value in the relational table. The most important thing for primary key is that it must have unique values. Now if we look into this table, here the primary key value is repeated. 1002 is typed twice. This might be a typo mistake. So if we search for this student, we will get 2 records, which is incorrect. Each individual record must be identified by a unique primary key value. So according to this rule, the primary key cannot be repeated. We can also say one additional thing, that it must not be null. This is the summary of today's lecture. First, we looked into some sample cases having potential issues. There were 4 cases, and all those cases were focusing on these types of integrity constraints. Then we defined the integrity constraints as it is a set of rules to maintain the quality of data in a database. Then we looked into the 4 types of integrity constraints. The first one is domain constraints. In these constraints, we take care of the domain values of an attribute. Then in entity integrity constraints, we saw that the primary key cannot be null, so there must be some sort of unique value for the primary key attribute. Then in referential constraints, we saw that this type of constraint is used in 2 interconnected tables, and the rule is that the foreign key values must be present in the primary key values in the connected table, or simply say that the foreign key values must refer to the primary key values in the second table. Then the last constraint was a key constraint, and in this type of constraint we say that the primary key values cannot be duplicated, so we must have unique values under the primary key column. This was all about integrity constraints. If you have any question, you can put your queries in the KCMS. Thanks.